Hey everyone, Mr. Fransky here. Today we're going to be starting Chapter 8. Chapter 8 is called Conic Sections. Conic Sections. Conic is things that have to do with a cone. And we're going to talk a little bit about cones today. And just kind of do a little intro to what a conic section is and look at the kind of the different types of conic sections that we're going to be talking about in Chapter 8. So let's get started. Let's start off with some bell work with some stuff that's actually going to show up a lot later in the chapter. Completing the square is going to come back with a vengeance in this chapter. So let's try to some completing the square problems. And then also just think to yourself, what is a cone? If you were to tell your friend, I want you to make a cone, what would you tell them that they would have to do? All right, so take a second on this, try to complete these square problems, and think about how you would construct a cone. All right, so first let's complete the square here. Remember, you take the middle term, you divide by 2 and square it. So 8 over 2 is 4, squared is 16, so you'd add 16 here. And then I didn't tell you to factor it, but let's factor it too. That'd be x plus 4 squared. I want you to automatically be able to get there. I don't want you to have to think about the factoring of it because you're completing the square, you should end up with a perfect square every time. I don't want you to have to think about it. It should be half of this guy right there, right? So the next one, negative 12 divided by 2 squared. That's negative 6 squared is 36, so we plus 36. And the factoring of that would be x minus 6 squared. Again, just half of this term. That's all there is to it. Next one, we got 1/2. Oh no, fractions. You guys can do it. Divided by 2 is 1/4. Squared is 1/16. So we're going to have 1/16 here. That would be x plus 1/4 squared. Half of that middle term squared. Also the square root of the last term, but you have to be a little bit careful with the sign then, right? Because this one, the square root is 36 is 6, but you got to be negative because of that sign in the middle. Next one, this one you might be able to just kind of figure it out. You could be like, well, it's 2x and 2x, and then what's the last term going to be? You might be able to think about it that way. Here's how I'm going to do it, because this is how we're going to do it later in the chapter. I'm going to pull out the 4, left with x squared plus 3x. And then I think, okay, what do I have to do here? Well, it's going to be 3/2 squared. 3/2 squared is 9/4. So I'm going to add 9/4. And then I'm going to bring the 4 back inside. Okay, so what do we have? We have 4x squared plus 12x plus 9. And then the factoring is easy. So this is going to be plus 9, and that is equal to 2x plus 3 and 2x plus 3. Okay, if it was a minus 12, it would be minus 3. That's all there is to it. So I should have a square there. Take my own advice. There we go. Okay, so a little completing the square there. We'll talk about that a lot later in the chapter. So now, what is a cone, and how would you tell a friend to construct a cone? So you may think, like if you have a circle, and you take a bite out of the circle, okay? So it ends up looking more like this. And this is like a piece of paper, let's say. You cut this out of a piece of paper, and then you join these two edges together. Let's use a different color to kind of show that. So if you took these two red edges, and you brought them together, right, it would make a really shallow cone. So it would be something like this. So there's your edge that came together. And then we'll kind of make the rest of it blue, if I can get the right color here. There we are. Okay, there'd be a circle on the bottom, around the back there. Right, so you made those two edges join together, and then it ends up creating this kind of a conic shape. And the bigger you make that bite, kind of the steeper the cone will be. If you end up with something like with even, it's not really like you've taken a bite out of a circle, it's like you've just used a little part of the circle. If you bring these two edges together, you bring those two edges together, you're going to have like a super tall cone, right? So it's going to kind of look like that, okay? So you might think about that as far as like a paper construction of a cone. Today we're actually talking about like a geometric or a mathematical construction of a cone and what that is. So what the heck is a cone? Well, what you do, the way that we describe a cone is you take a line, okay, a line that has any kind of an angle to it, and it could be kind of like a 45-degree angle like this. It could be super steep like this. It could be mellow like that, right? Any one of these. And then what you do is you spin it around an axis, a vertical axis. So I'm going to put a vertical axis in here. It's called the axis of the cone. And then what you do is you pretend that this thing is welded to the axis right there. Then imagine taking the axis in your fingers right here and spinning the axis. So the line is welded to the axis, so it's going to spin around the axis. If you pick any point on the line, what kind of a shape is that going to trace out? I think it's going to trace out a circle. Right, so you have a circle here, you have a bigger circle here, you'd have a little circle down here, bigger circle down here. And if you imagine what this thing is going to paint out in the air, so when you were at 180 degrees, you'd have a line that looks like that, right? It goes on forever. And then you end up creating this cone. It's going to have a bunch of circles, right? An infinite number, okay, kind of at every level here. But it ends up creating this thing that we call a cone, okay? So it would be kind of like this. Now, there's some important misconceptions about cones, things that I didn't understand when I first learned about conic sections, so I want to tell you right now. First thing, the reason I put the arrows on it is because it goes on forever. Okay, it goes up and down forever. So what that means is it's not like an ice cream cone. Like an ice cream cone, first of all, only has the bottom, right? Or only one half of the cone. Okay, that's actually the next thing I'm going to say is there's a top and bottom. Okay, so there's a top and a bottom. I used to think that, a cone, I think when a lot of people think about a cone, they think about something like an ice cream cone, or like you can make out of the pieces of paper that we talked about in the last slide, where that's really just one half of the cone. And more so, it stops, right? It's finite, right? It's kind of like you see the back of the cone there. Let's say it's an ice cream cone, so let's make some checks on it. Why not? Okay, so a lot of people think about a cone just like half of the cone, but it goes up and down forever. It never stops. I used to think a cone had like a top and a bottom. It doesn't. Well, it has a top and a bottom piece, right? It's kind of like an hourglass. But it goes up and it goes down forever. So this cone goes on forever in both directions, okay? So you can make as many of these circles as you want. Generally, they make one of them to kind of show that it's a three-dimensional object, but it goes up and down forever. So a cone goes infinitely high and infinitely low. Top and bottom piece like an hourglass. The other thing is that, do you think this is hollow or filled in? The way that I describe, you create this. You take a line, you spin it around an axis, and it's just like if that line was painting out in the air, was painting out this cone, it's hollow. Okay, so a cone is hollow. All right, so there's nothing on the inside. It would be empty, kind of like an ice cream cone. Okay, so this is how we are constructing a cone. If you have trouble kind of visualizing this, I have some other ways I can show it to you, so come and talk to me. That'd be just fine. So now, let's think about what a conic section is. So here's by definition from the book. A conic section is a shape created by the intersection of a plane, like a piece of paper, and a hollow cone. So the simplest conic section, every conic section is made from a cone that has a top and bottom, but some of them don't involve the top and bottom of the cone. So I'll just draw kind of one half of the cone. The first one's going to be if you took a piece of paper and you sliced straight across the front of the cone, like this. So it was parallel to, let's say, the base or the top of the cone. What kind of a shape would you see if you cut the cone straight across the top and looked at the top of the cone? I think you'd see a circle in there, right? Okay, so a circle is a conic section. If you took a piece of paper and just cut straight across a cone, remember it's hollow, so all you're seeing is the intersection. So it'd be the edge of the cone, right? And you can put that piece of paper anywhere you want. The lower you go, what's going to happen to that circle? It's going to get bigger. Okay, kind of the basic construction of a cone, right? So a circle is gotten by taking a plane that is parallel, plane that is parallel to the base of the cone. And it's weird to think of the base because we said it goes on forever in both directions, right? But you could also say perpendicular to the axis, right? So the axis here, that piece of paper is going to be perfectly perpendicular to the axis. So the circle is our first conic section. The next one, if we take this piece of paper and we tilt it just a little bit. Now this side, like I said, I'm only going to draw one half of the cone because it's not going to intersect the top. So I'm going to tilt it just a little bit. So if I ended up with something like this, let's go across the front there, across the back like that. So if you tilt that just a little bit, instead of seeing a circle, what are you going to see? I think you're going to end up seeing kind of like an ellipse shape, right? Some people call it an oval, right? But this is called an ellipse. Okay, an ellipse is the fancy word for an oval, the fancy kind of math word. So the math kind of lingo, if I could spell math right. So the fancy math word for oval. And ellipses, we're going to talk a lot about ellipses and kind of their practical applications. There's a lot of them, and they're really cool. So what is happening here is we've tilted the plane just a little bit, but not enough so that it's going to touch the top part of the cone. Okay, so this plane is tilted. Okay, so it's tilted to intersect with that cone, right? And it's just the edge of the cone. So once again, it's just the border, right? It's not a filled-in oval. It's just the edge. Okay, so the plane is tilted, but not enough to intersect the top. Another way to say that is not needs an O there. Okay, so another way to say that is the plane is not yet at the same angle as the edge of the cone. Okay, so we have not tilted it enough so that it's parallel to the edge, right? We just tilted it a little bit. So circle, straight across. Ellipse, just a little bit of a tilt. That's all we've got so far. Okay, I've got two more conic sections I want to tell you about. So the next one is what happens if we keep tilting to the point that that it's parallel to the edge of the cone. So this time I'm going to make the entire cone. Kind of both of these that were last two that we're going to talk about are going to be kind of important for the entire cone. So here's our cone. If we tilt it to exactly the point that it's parallel to the edge of the cone. So I'm going to try that better, draw it parallel here. So here's our plane. Here's kind of the back of it, right? It's coming back across the back here. Now, what's weird with an ellipse and a circle, it came out the other side, right? So a circle came out the other side, and ellipse too. So here's our circle. If I can draw that, it's a little bit too small. Sorry about that. So a circle came out the back side like that. It's hard to draw a dotted really small like that, sorry. And an ellipse did as well, right? So an ellipse, we were tilted a little bit, and it came out the back side. This one, if I have a plane, planes technically go on forever, but we're just drawing the part that's interesting. If it's going down here, is it ever going to come out the other side of the cone? If it's parallel and this line is going forever, then it's going to keep going down, down, down forever, right? And what's going to happen is the back of it, a lot of people think that about this, I think it's going to be a triangle. But think about it this way, the back of it is actually going to be curved. So it's going to be something like this, okay? And I should probably dot that back side. So it's going to come up like this, kind of come around the back, and then it's going to be dotted going down. Okay, so we have this shape, and if you were to look at it from the front, it would look like this, and it goes down forever. What kind of a shape is that? That is actually a perfect parabola, which is crazy to me. That you can take a cone and slice it with a plane that is exactly parallel to the edge. Okay, so this is a plane that is parallel to the edge. Parallel to the edge. Okay, so we started straight across, then we tilted a little bit in order to get that ellipse. And now we have tilted it so much that it's parallel to the edge and it's never going to stop. This is going to go down forever on both edges of the cone, right? And it's going to create this parabola. It's going to go on forever in the downside of both directions, and it's going to be curved along the back. Okay? So, parallel to the edge of the cone. It doesn't look like edge. Let's do better. Okay, now of course, and would it intersect the top? No, because it's parallel, it's going to be right, like just short of this side, right? It's never going to touch. So the next one is if we keep rotating it, if we keep tilting it, it's eventually going to hit this top part of the cone. So what is that going to look like? Easiest way to do it is just say we've gotten to the point where it's kind of almost vertical here. Okay, so here's our cone. Remember, it's going on forever in both directions, top and bottom. Okay. So if we've tilted the plane so far that it's now cutting across both the top and bottom of the cone. Okay. So what's going to happen is it's going to have an intersection on the top here. It's going to have an intersection on the bottom as well, right? And it's going to go on forever up and forever down because we're cutting into the part of the cone now that's like on the interior, right? This line's going to keep going that way, that way. So it's going to be cutting down. I shouldn't really even have a bottom edge on this, right? Because technically it just keeps going down forever, right? And this backside will keep going down too. What's going to happen is on the bottom, once again, we'll have a curved top. And it's going to kind of go down like that. We'll dot on the back. Okay? And then on the top, same deal. We're going to have a curved bottom here. Dot on this side and solid on this side. But there'll be like a gap in the middle. So if you look at it straight on, like from this side, what you would see is you'd see like a curved thing on the top like this, and a curved thing on the bottom like this. Some people think it's two parabolas. This is actually what's called a hyperbola. Hyperbola. Common mistake kids make is they call it a hyperbole. That is a part of speech. It's a speech device. It's different from a hyperbola, which is kind of two curved shapes pointing at each other. And so this is anything where the plane is steeper. It has gone beyond the angle of the edge of the curve. Okay, so the plane is steeper than the edge. Okay, and it's going to create this little thing, this kind of hyperbola looking thing. It's got one on the top and one on the bottom. We'll talk about a lot of cool little applications and places that hyperbolas show up later in 8.3, I think is where they come up. So we'll talk about those as well. So parabola, just one, right? Because it doesn't intersect the top. Hyperbola has these two things. Sometimes you see people, you can do one that's straight vertical. right? Straight vertical might be the easiest plane kind of to do for a hyperbola because it's going to intersect the two parts of the cone. But it doesn't have to be vertical. It just has to be steeper than the edge. Some years, this year we're not going to have time, but some years I will bring in Play-Doh. And so if you want to try this on your own time, you've got some Play-Doh at home, you can create a cone and start going at it with like a little plastic knife and cut kind of the edges off. I also have some wooden cones up at the front of the room where you can kind of take pieces off of them and see these different conic sections. So if you need something you can hold and touch and actually see these, that's not a bad way to go. So where are we going with this? You can actually graph these things on a plane. Okay, so we're going to be looking at stuff that kind of looks like this. So like hyperbola, maybe, something like that. And it has to do with finding these points. And there are actually some asymptotes that deal with hyperbolas. And every single conic section. So circle, ellipse, whoops. One ellipse, I think. I'll check that later. Circle, ellipse, parabola, and hyperbola. All can be graphed using this equation. Some of them will be zero, right? So like parabolas we know are like y equals x squared. So there would be a y, there would be an x squared, but there wouldn't, and maybe a constant, but there wouldn't be anything else, right? For an ellipse, parabola, hyperbola, or circle, there's some parts of these that will be present and some parts that will be gone, right? And these kind of are some nice pictures over here that I found online. So hyperbola, remember, is going to intersect the top. Parabola is parallel to the edge. Here's our ellipse. Here's our circle, just much better than I can draw them. Here's kind of a nice picture using both parts of the cone, showing all those different ways that we can have the conic sections. It's kind of cool. So, fun to play around with. We're going to be focusing more on kind of these equations to put them on a coordinate plane. There's some really cool geometric ways that the coordinate plane interacts with how they fit in a cone as well, especially how you can fit like a little sphere inside of the cone that would touch the conic section and also the edge of the cone. And we'll explore all of that kind of in the coming videos. I believe that's all I have for you guys. So I love you guys. That's why I'm here. I'll see you in the next video about parabolas.